जी अऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम। The course of multivariable calculus and transform that we discussed in our today's class. Regarding the course, we have the books which are mentioned over here, and all these three books we are using in our course. Further, we start the session with the complex number, basic algebraic expression, complex number properties, and we start with the concept of complex numbers, that is the real number or solution of the equation. And we all know that if the value of x square equal to -1, and further, if we want to find the value of x, then x equal to square root of -1, and this would equal to the imaginary value that is denoted with iota. Iota is the property of imaginary values, and it is also represent in the aspect of imaginary values. In most of the books we are mentioned iota in j as well. So two entities I and j is related to the imaginary values, and these having j square or I square equal to -1. And if we want to find the value of ओके, मैं आवाज़ थोड़ी लाउड कर लेता हूँ। थैंक यू। फर्दर, मैं ये बता रहा था कि इमेजिनरी वैल्यू जो कि यूनिट के बराबर है, द नंबर आयोटा इज कॉल्ड द इमेजिनरी यूनिट। इमेजिनरी मीन्स द वैल्यू ऑफ आई इक्वल टू square root of -1. So iota imaginary equal to square root of -1. These are related and used in the complex number. Numbers of the form of I a plus iota b, where a and b are the real number called the complex numbers. In complex number, we all know that it is equal to the z equal to a plus iota b. So we know that z equal to a plus b iota. Another aspect is z equal to x plus y iota, as well as the z equal to, it can also be represented a equal to z equal to a minus b and iota, as well as the x minus b iota, as well as the x plus, so it is represented in these values, as well as the a plus b with j as well. So in complex number, which is represented by z, represent as well as I and as well as the imaginary value j. in plus and in minus as well. A minus B of J. Same as here, that X plus Y J from equal to X minus Y with J. So complex number in most of the books we represent with the iota I and with represent with the imaginary value J as well. So there are the number of books which is represented. Uh, I have to remove the annotation. Uh, these are the books. So in these books, some of the complex number variable are represented with imaginary value I and as well as the J. So the notation which is represented in the form of complex number Z I have mentioned over here. So further moving towards the aspect of X plus IY, where A and B are the real numbers and called the complex number. In this complex number, X is the real part and Y is the imaginary part. You can see the number which is next to the I, that is B, is the imaginary value. And the first term, it is called the real term. So real plus imaginary is the combination of complex number which is represented by Z. So moving further towards the concept of complex number, which is A plus B iota, and A and B are the real numbers, and the combination of two things become complex number as well. Non-linear complex number are the non-real complex numbers are A plus BI, that is iota. B is not equal to 0. So it is the real complex number in which the imaginary value is 0. Real numbers A plus B iota and B equal to 0. This will also be the real numbers. We further moving towards the uh, irrational numbers and the rational numbers. If the real number complex are divided into two parts, and here you can see the rational numbers also divided into two parts, that is integers and the non-integer numbers. Basic complex numbers are the two types, that is provided equal to the imaginary part is equal, and we can say that if A plus B iota equal to C plus D iota, then we can say that A equal to C and B equal to D. So it is a self-explanatory expression in which you can relate the terms A with C and B with D, equating, comparing. These are the aspect by which we can notate the value A and B. The basic complex numbers, we can say that uh, if B equal to 0, then this expression, that is the A plus B iota equal to A if B equal to 0. So the set of real numbers is the subset of the complex number as well. If both the value, if A equal to 0 but B not equal to 0, then the complex number purely will be imaginary. So a pure imaginary number of the real is 7 plus iota B with B, A and B not equal to 0, then non-real complex numbers. The form A plus B iota or A plus iota B is called standard form. So standard form of what? Standard form of complex number. These complex number can be in plus as well as in negative as well. In some of the upcoming in future class, I will also be map these complex numbers in the form of mapping of complex number in which the real domain of x's and imaginary domain of x's, we place these complex number in different aspects, and that how of the nine combination of these complex number would be represented in the graph form. So in upcoming classes, I will discuss these things. Uh, the expression of square root of minus a, that is also related with the value in which it is represented by square root of minus a. If this polynomial of expression represented in the form, we can also say this iota square root of a. So these are the two interconvertibility terms in which we can relate and represent the complex number of imaginary as well. Notation. Okay. For the example, we can say that the write as the product of real number. If the expression which we discussed in our previous slide, that is the square root of minus a, in real value, it will represent it in the form of a square root of minus 16. So if in a square root minus 16 represent, we can say that it would be represented in the form of uh, square root of minus 16, that is iota square root of 16. We all know that in a square root, minus 1 would be multiplied with 16 and itself minus 1 of square root represent of iota. And square root of 16 having the value will be 4. 4 iota is the result of this expression. Oh, coming towards the next part of example of if the expression of square root of minus a represented as an example in real number, that is square root of minus 70. So in 70 represent in the square root, then minus 1 multiplied by 70, that minus 1 square root would be represented by iota, and square root of 70 with having the LCM values, and we got the value of square root of 70 in real number and represent with iota as well. Another third category of example with the square root of minus a would be represented in third question, that is square root of minus 48. If a square root of minus 48 represent here, so solution of square root of minus 48 would be represented, all we know that iota is square root of 48. And if we taking the LCM, the roots subdivision aspect of 48 would be 16 into 3, and it will be represented 16. If we take the square root of 16, then we got the value of iota, 4 iota square root of 3, because 16 having the square root of value 4, but 3 having a square root would be the square root of 3. So this expression of minus 48 having product of radicals answer would be 4 iota square root of 3. Up till now, if anyone of you having the kind of question or query regarding the session, you may ask. I will answer the kind of question and resolve your queries. Otherwise, we continue the class further. So this is the example, which is consist by three parts of A, B, C. The operation of complex number we will discuss over here. The products or quotients with negative radicals are simplified by first writing square root of minus a as iota, square root of a. So the positive number, it would be represented in this aspect, and then the term of iota square equal to -1. So this expression would also be represented in mathematically, but it cannot be calculated by calculator. If you enter this value of square root of -1 in calculator, it would be the math error. It would not be calculatable by the calculator. So in writing based mathematical rule, this expression would be represented iota square equal to -1. So, uh, so this is the rule that when working with the negative radicals, use definition, it would also be mathematically represented as square root of a in minus equal to iota square root of a. Before using any of the other rule for the radicands, we further express this expression that if two terms of radicals square root of c multiply by square root of d, we can say that it would be combined in product form of a square root, that square root of c into d individually square root of c multiply by square root of d is valid only when c and d are not both negative. So this expression would also be represented, you can see c into d. This looks like square root of -4 into -9. Both the minus would be multiplied with each other, and 4 nines are 36. That is represented in a square root, and we know that the square root of these things would be in 6. Square root of 36 would be 6. So how can we approach this answer? It's a simple that if we have both the values in square root in negative side, both minus would be multiplied and it be converted in positive. But if we if we have only the one minus sign, so square root directly cannot be possible. So it would be looks like iota of 6. Coming towards the next aspect, that is square root of 4 into square root of 9. So it looks like that value of square root of 4 would also be in 2 iota, and square root of 9 would also be represented in 3 iota. 2 3 is 6, and iota multiply with iota would become to iota square. And iota square would also be represented in square root of -1. So it looks like in this form. So both these multiplication would not be equal if we uh, solve the individual aspects. So we need to combine both these terms, like in this aspect. We cannot solve the second approach as the method. So up till now we discussed the complex number multiplication rules, and now we further approach to the concept of that radicals with the multiply as well as the divide. Simplification of this answer towards the concept of both the values, that is square root of 20 divided by square root of -2. So how can we solve these things? We further need to get the value of LCM of -20, but we know that if square root of -20 represents in this aspect, then iota square root of 20 would be represented in this form, as well as -2 of square root would also be represent iota square root of 2. Both the imaginary values in numerator and denominator would be cancelled with each other, and we got the single term of square root of 20 divided by 2 in this aspect. So 20 divided by 2 would also be represent square root of 10. So square root of 10 would be the answer, And the quotient rule radicals with the division of both the numbers. If in individually in square root, then it would be in last answer would be the square root of 10. This is a simplification of dividation of complex terms if it is represented in a square root of -1. So another aspect of example 3, the question involving a single radical. So how can we simplify this term of complex number? It is if represent in this aspect. So coming toward the aspect, that is, we first simplify the square root of terms which have the negative sign. So if we taking the LCM of -128, by taking the rule of LCM, we got the factors -64 multiply by that bracket is donate or represent multiply sign. So -64 multiplied by 2, and both the terms of -8 and 4 represent over here. After that, we know that the 64 of minus having the value in sense of LCM would be 88 iota, and the factor 2 we cannot taking the value in the factor. So -128 would be represent in short 8 iota square root of 2, and both the value of numerator -8 in black text and minus and 4 represent over here. So this is the simplification aspect of these things. We coming towards further steps of simplification, that -8 plus 8 iota square root of 2 divided by 4, by taking the value of square root of minus value 8 iota, and be sure to factor b before the simplifying. We taking the common of 4 from numerator, and both the 4 numerator and denominator would be cancelled with each other. The simplification of answer in lowest term would be -2 plus 2 iota the square root of 2. So this is the answer that we represent, that we see over here in larger complex term. After the simplification, the lowest term, we got the value -2 plus 2 iota square root of 2. So up till now, we have discussed this third example of complex number simplification. You can see this term is a complex one. How can we see? Because z equal to a plus b iota. So it follow the rule of complex number. So if there is a representation of iota value, we can say it's the complex term, complex number, which is also be denoted a plus b iota. So addition and subtraction of complex number, this rule is related to the addition of two complex number. If z1 equal to uh, z1 equal to a plus b iota and c plus d iota. If we add both the terms, we can say a plus c, these are two real terms, and b and d are the imaginary terms. So both the addition of these terms would be represent a plus c plus b plus d iota. Okay, further, if we going to the subtract aspect, that is a plus b iota minus c plus d iota, both the value of a minus c and b minus d of iota represent over here, and the addition represent the above side, and in below we can say the subtraction of complex number as well. Continuation of addition and subtracting of complex number over here, you can see that if we have the first factor 3 minus 4 iota plus minus 2 plus 6 iota is the second factor. If we need to add both these terms, we need to represent sequence both the real terms and both the imaginary terms with each other, fulfill the operation of addition as well as the subtraction, and we got the value of addition and subtraction of terms. So both the terms of 3 and minus 2 with each other and minus 4 plus 6 with each other. After this combination, the real part with each of one and imaginary part with each of one as per the commutative, associative, distributive property. Both three terms have the same meaning. So combining the real term, combining the imaginary terms, and after this addition, 3 minus 2 would be 1 and minus 4 plus 6 would be plus 2 iota. So this is the simplification of addition of a complex number. If we having example 4a, we got the solution 1 plus 2 iota. Coming towards the next example, if we add both the two complex number minus 9 plus 7 iota plus 3 minus 15 iota. So 9 plus 3 would be minus 6 and 7 minus 15 would be minus 8 iota. This is a simplification of complex number and we find the answer. So this is how we can find the value of complex number. Coming towards the subtraction of complex number, minus 4 minus 6 with each other, and 7 minus minus plus of 7. So we can say that the minus 10 plus minus 10 plus 10 iota having the solution of complex number, and we got the answer. Coming toward the next subtraction of the complex number, minus 12 minus plus 12 minus 8 minus 5 iota with minus 3 iota, and having the value minus 12 with minus 8 and minus 5 iota with plus 3 iota, and we got the solution, and from the simplification would be 4 minus 2 iota. So this is the example of subtraction of the complex number. So coming towards the next basic aspect of the complex number, that addition and multiplication, the basic complex number, that if we have the z1 equal to 2 plus 4 iota and the second complex number z2 equal to minus 3 plus 8 iota. So if we need to add both complex number of z1 plus z2 and b, that is a multiplication of these two complex number z1 and z2 as well. So further aspect we coming towards okay, coming toward the solution. What happened? Why? Okay, now working. If we add both the two complex number, that is z1 plus z2, so we need to arrange both the real values with each other and as well as to arrange both the imaginary value with each other. So we know that 2 minus 3 and 4 iota plus 8 iota with each other, and the value of real term would be -1 and the value of imaginary would be plus 12 iota. So up till now we discuss the example 1 of complex number addition z1 plus z2 with the solution. Coming towards the next example of 1 part B. So how we can multiply with each other, you can say the factor of one of complex number z1 and z2 over here. So the real value 2 plus 4 iota would be multiplied with -3, as well as the 4 plus 4 iota multiplied by 8 iota. So each of 1, 3 multiply with 2 and 4, we got the value -6 minus 12 iota, and the 8 multiply with 4 plus 2 plus 4 iota, and we got 2 into 8 16 and 4 into 8 32, as well as the this factor having individual iota as well. So it would be 8 to 16 iota and 32 iota square as well. So arrangement of 32 iota square would be, we know that in previous slide we discussed iota square equal to -1. So this -1 would be multiplied with plus 32 and would be -32. Both the 32 and 6 would be the real number. So we arrange both these two terms, -6 -32, and as well as the imaginary terms with each other, that is 16 and 12. Both the real numbers of 6 and -32 add each other, and we got the value of -38, and 16 minus 12 add with each other, I mean subtract and addition with each other, and we got the value of 4 iota. So in this slide we have concluded the example of complex number of addition and as well as the multiplication. Up till now, any one of you have the kind of question, query, or difficulty, you may ask. I will answer the kind of question, resolve your queries if you have. So another example of complex number multiplication, over here you can see uh, 2 into 3, 2 minus 3 iota multiply with 3 plus 4 iota. That how can we solve this term? 2 multiply by 3 plus 4 iota. So 2 multiply by 3 and plus 2 into 4 iota with each other, and -3 iota multiply by 3 and -3 iota multiply by 4 iota. So how can we solve these terms? Individual or factor, with 2 into 3 is a 6, 4 2 is a 8 iota, and 3 into 3 9 iota, and 4 is a 12 iota square. So in blue color text, that iota square represent of minus minus plus 12. So same iota square -1, so it would be transformed to plus 12, and before that plus 8 iota minus 9 iota with each other would be form minus iota. Subtracting with each other, both the real values of plus 12 and 6 would be 16 minus iota. So this is the solution and answer of this question. We have the less than a minute. This session would be concluded of Zoom. Up till now, you have if any kind of question, query, or difficulty, you may ask.